Hello, and welcome to the Glasshouse webcast. Today's topic, which cloud should be in my 10-day forecast, will be presented by Jim Demalakis, Glasshouse's CTO and resident cloud expert. Jim brings over 25 years of experience in systems, storage, data protection, recovery, and cloud computing with a strong focus on architecting and implementing highly efficient enterprise infrastructure solutions. Ladies and gentlemen, Jim Demalakis.
Thank you, Natalia, and good morning, everybody. Today we're going to talk about a subject that is becoming really a frequent topic of conversation when I meet with clients, and that is, of course, the cloud. We've actually reached a point where cloud success stories have steadily begun to appear. The initial generation of cloud enablement tools has been released, and an understanding of appropriate cloud use cases is beginning to clearly emerge. So the result is that the cloud is now becoming not just a feasible option, but in the minds of many, an inevitable one. This session is going to take a look at the state of the cloud today and lay out the proposition that the world of IT is changing and why this is so. Next, we're going to talk about the cloud model and the vision promised by the cloud. One of the challenges associated with formulating a cloud strategy is that the term cloud is applied to a broad range of technology and deployment models, and we're going to delve into this subject, and I'll share our perspective there. An even more critical consideration for many organizations is the question about location and control, where the cloud should reside, who should control its underlying elements, in other words, public versus private cloud. Then for those considering building a cloud, we'll highlight some of the key considerations in developing a private cloud. And finally, we'll wrap up with some time for Q&A. So let's get started. There have been a wide range of social, business, technology factors that are changing the face of IT. In the 90s, we saw the server explosion with the data center, within the data center, with the count of dedicated servers multiplying dramatically. In the past 5 to 8 years, we've had a reaction to that explosion as technologies like virtualization drove improved utilization and reduced physical server footprint. On the business side, the nature of demands on IT is changing as well as the drive for increased responsiveness to market demands, the push for greater revenue and margins has become more urgent. Responsiveness and flexibility really have become major competitive differentiators in some cases, and in others, they're actually basic business requirements. Likewise, regulatory needs and considerations related to things like privacy, compliance reporting, archived data retrieval, all of these things have increased the pressure on IT from a service perspective. We also have the social networking revolution happening, and especially new ways of accessing information. Users want to be able to get to data in a variety of different ways, anywhere, anytime. Essentially, the fortress of IT is being scaled as users with new devices are demanding it. So, also a long-standing problem within IT, and particularly for those of us for whom things like storage have been near and dear to our hearts, is capacity and demand management. IT hasn't been able to get accurate demand forecasting requirements from business and doesn't have adequate reporting to provide visibility into actual consumption, and often lacks an effective way to influence usage behavior to reduce that consumption. So as a result, what's evolved is essentially a just-in-case approach as opposed to a just-in-time approach to building out capacity within the data center. And the trade-off is clear. The risk of, you maintain a risk of overcapacity, meaning you lose money, or undercapacity, meaning you lose business. And finding that balancing act has been extremely difficult, and organizations just haven't been all that successful at it. So the net of all this is that nobody is really happy End users view IT as a barrier to getting things done. It takes too long or it's too slow. Finance sees IT as an increasingly large money pit. The CFO is particularly unhappy because he doesn't have visibility into where the money's going or what value is being received for a certain amount of incremental spending. And IT is unhappy too. They have all the cost control pressures and demands pushed upon them, but few ways to influence and modify that behavior. Things like lack of unit cost metrics, lack of tools to provide visibility, make the job impossible. The missing element here, in our view, is a services-centric focus as opposed to the traditional techno-centric focus that pervades business as usual. And when you get right down to it, the truth is that when it comes to managing infrastructure, few companies can do it all. In fact, there's always a list of tasks or projects that enterprises, some can handle some very well, others not so well, and others not at all. So the degree of success varies, and the impact, as shown in this chart, varies too in regard to how it affects the overall health of the business and ability to support the business overall. I'm not going to talk, this is somewhat of an eye chart, and in the interest of time, I'm not going to talk in detail to this chart, but I think you get the picture. We often see organizations really focused on firefighting and maintenance kinds of activities, and there's a lot of should-do kinds of things that never really quite find time to get done. So let's shift and talk about the cloud vision. This is, and I'll preface this by saying this is a somewhat idealized view of the cloud, but it does reflect, the reason I'm doing it is it reflects the promise that people see and why they're so interested in the cloud. The technology evolution that I alluded to earlier, led by virtualization and the internet, along with network data storage, forms one enabling foundation component to the cloud model. In our view, there's also another critically important piece, the service provider model, adopting a services-based mindset, including service catalogs, SLAs, per unit costing, ends up moving the focus of discussion from how, i.e. what kind of technology you're using, to what, meaning what IT service business requirements are needed and at what price. The cloud carries this to the next level by providing things like automation and self-service provisioning, leading to new levels of scalability and flexibility. So just briefly touching on what we mean when we talk about the service provider model, here's our view of the key elements. So first of all, each service offering provides a different service level requirement to be satisfied at a known cost. So that's the standardized service catalog. A service level agreement between service provider and recipient is a foundation, we believe, for business alignment and more of a partnership with business. All too often, problems come up because of misguided assumptions or misunderstandings. SLAs help to clarify that. Another key element is how it's delivered, so mature policy and procedure. The more, as processes mature, they become more repeatable, documented, measured, and finally support continuous improvement, meaning they get delivered in an efficient way and SLA needs are clearly able to be met. And then costs. Without a clear cost model, it's hard to drive behavior and understanding, and so that's an essential element. So the connection here to the cloud is that the cloud combines this services mindset with, as I said, the automated fashions, and also leveraging a multi-tenant shared model. And this really provides that quantum leap in scalability and flexibility for users. So the result, if we look at this admittedly idealized cloud experience compared to what we were talking about before as a typical IT experience, we see a lot more happiness. End users are happy because they're getting what they need when they need it at predictable cost, and, by the way, conversely, can stop using and paying for things that they don't need any longer. Finance is happy because of cost savings and efficiencies that can be driven through the model and the ability to impact cost-conscious decision-making. And even IT is happy due to better aligned service offerings, leading hopefully to less user dissatisfaction, and an optimized automated environment and improved operational efficiency, meaning less time fighting fires and more time hopefully improving and building on those should-do kinds of activities that they can never find time to get to. So, how do we get to all of these wonderful, or at least a few or most of these wonderful things? As I'm sure you're aware, there are a variety of approaches, and deciding on that right approach or combination of approaches depends on understanding needs and objectives in the organization, technical capabilities, corporate culture, and also business climate and environment. They all impact in what direction an organization should use. I've alluded to attributes of the cloud, but let's highlight some of them one more time briefly just to level set, because the degree that they're realized can vary depending on the type of cloud. So I've already mentioned service catalogs and standard menu of services, the cost transparency aspect, self-service, automation, by automation, that automated dynamic provisioning and overall lifecycle management, the ability to scale out, scale back in a flexible manner, demand capture and capacity management, metrics and visibility and control, and reporting on service delivery and consumption as well. So all of those are key factors. So one way of considering clouds is with regard to the type of service being delivered. Traditional IT provides an entire stack of services, often managed in a silo or some sort of a la carte manner. So if we look at these on the left, we've got from the bottom, we've got the traditional infrastructure, networking, storage, servers. Layered on top of that is virtualization, operating systems. Then we get into application development components, middleware, runtime engines, and then finally the applications themselves and their data. The cloud model essentially packages some or all of these functions and bundles them and delivers them as a standardized set of services. So with infrastructure as a service, the lower part of the stack becomes the service offering. So servers, typically virtualized servers, are delivered with some amount of CPU, memory, storage, and network capacity, usually in selectable bundles or through a structured menu of options, including a choice of operating system images. This bundle is then provisioned automatically and made available to a user who might be inside or outside of IT, who can do with it pretty much as they please with regard to those upper level elements in blue. Clearly, a great example of this would be in the public cloud space would be Amazon's Elastic Compute Cloud. Platform as a service extends this further by making the development platform, the runtime and middleware components, part of the bundle of service offerings, meaning that the user only needs to focus on the application and data. The server environment and everything underneath it is abstracted to much more of to a much greater degree, and is an approach that is enjoyed very much by developers who really just want to focus on their application. Examples of this, again from a public standpoint, would be Microsoft's Azure service, also things like Force.com. The platform is a service element of Salesforce.com, and there are a wide range of other options as well. Software as a service is really a full outsourcing of the entire stack as a particular service. So the focus is an application and all of its supporting components being delivered as a service, thereby eliminating all underlying management concerns for any of those boxes underneath on the part of the user, who's completely free to focus on interacting with the application. And again, from an example standpoint, Salesforce.com, Office 365, many other examples as well. So clearly, all of these models offer benefits. None are mutually exclusive, and an organization could potentially leverage all three to meet varying sets of requirements. Another key aspect of the cloud is the manner in which it's deployed. There are three fundamental deployment offerings that we can talk about, and each can provide key benefits that we expect from a cloud to varying degrees. Really, the key determining factors become cost, business need, and comfort level, for lack of a better term. To many, when we talk about the cloud, it's the public cloud that comes to mind. People think of the Amazon model. And this is really the pure utility cloud with no capital expenses and a true pay-per-use model. It's fully shared, multi-tenant. People can select the services they need, sign up with a credit card within minutes, have the instance available to them, and they can decommission it just as quickly. The private cloud also delivers utility model services. The key difference is that the cloud infrastructure is owned or leased by a single organization and is operated solely for that organization. So inevitably, there are CapEx as well as OpEx costs, and any resource sharing that occurs really is limited to groups within that organization. And obviously, it's also possible, and in our view, it's actually very likely over time that organizations will want to deploy both private and public clouds, a hybrid model. This could be structured in several different ways. It's possible that certain application functions might be delegated to the private cloud and others to the public cloud, with the clouds bridged together to provide proper information flow, business workflow function, data exchange. Another possibility is to provide a unified, equally functional private-public cloud where the public cloud becomes essentially an extension to the private cloud. So where demand, for example, in the private cloud exceeds a certain threshold, that demand becomes satisfied by the public cloud. This cloud bursting model provides the opportunity to really rethink data center and infrastructure capacity planning, where the need to satisfy peak demand drives a significant amount of capital expense. Organizations invest in infrastructure that sits idle for a large part of time. The hybrid cloud is a way to with its flexible expansion capacity to meet that expected or even unexpected demand in a more cost-effective manner. So looking a little deeper at the public versus private and what some of the potential trade-offs are. As I said, many of the key attributes, self-service, automated provisioning, consumption cost visibility, potential savings can be attained in either public or private, but in other areas there's some clear differences. One of the things that I will say, is regardless of the approach, either way, a much higher level of both agility and responsiveness can be attained in either model. Some of the obvious differences, though, relate to the OpEx versus CapEx issue, the degree of elasticity. Clearly, a public cloud vendor has the opportunity to leverage any cost infrastructure investments across a much broader universe, whereas only the largest organizations would be able to approach that degree of elasticity in a private cloud. Another consideration is latency. Application and business tolerance for latency needs to be understood, and whether or not a public cloud can provide an acceptable level of service, where in a private cloud that's less likely to be a concern, particularly in a private cloud housed within the organization's own data centers. Security is often the chief concern when we talk about the cloud with clients. It's the chief concern voiced by IT. And while it's clearly an important issue, it shouldn't be overstated or dealt with simplistically, in our view. It's inconsistent, for example, for one part of an organization to outsource critical CRM data to a software as a service provider, while another part of an organization is disapproving the outsourcing of third-tier archival data to a cloud storage provider. The truth is that many public cloud vendors have more rigorous security in place than many of the organizations themselves. So it's important to truly understand the security needs and to be able to evaluate this carefully. It's clearly a major issue, but it shouldn't be answered, and public clouds shouldn't be immediately viewed as not being secure. Another critical factor is characteristics of an application in terms of the ability to effectively leverage the cloud model. Application behavior and needs will play a big role if and what kind of cloud an organization can potentially transition to. Some of these attributes are, well, clearly virtualized is kind of table stakes for the cloud. Likewise, anything that's not running on a current version or pretty near current version of an OS platform is pretty much off the table as well. The major success stories in the public cloud have been based on applications specifically designed to and written to exist in the cloud as opposed to the traditional data center. So some of those key attributes of those applications would be statelessness, latency tolerance. If latency is indeterminate, being able to handle varying kinds of conditions gracefully is a critical need. Self-healing, being self-resilient as well. And so if these are the ideal attributes of a cloud application, many people see the public cloud primarily for greenfield opportunities where an application can be designed from the ground up to handle that environment. Where a traditional application expecting robust underlying infrastructure and always connected behavior and so forth might fail. So the truth, of course, is that most organizations lack both the resources and business justification for rewriting a large number of applications. So while there may be greenfield candidates, it would certainly be wise to plan new application development with the public cloud in mind, being able to potentially move there. But a large percentage of IT will not be able to migrate to the public model, and will be moving more to a private cloud model where possible. So I guess the key takeaway from this is to make sure that your organization is actively planning their next generation of applications with a strong consideration toward cloud readiness. So given that the private cloud is, and this is borne out by our conversations with clients, is where a lot of people are interested in moving to in the near term and see the public cloud as more of a long-term goal, what are some of the things that you need to consider in that regard to regarding readiness for the private cloud? First relates to cloud architecture. Now, don't be scared. I know this is a bit of an eye chart, and I'm not going to dive into all of these little boxes, but I do want to highlight some of the major functionality considerations that are required. Cloud services at the top of this picture. In a private cloud, typically that means we're talking about infrastructure as a service or platform as a service. Really, from a practical standpoint, software as a service is usually a public cloud service. Most organizations have the lower tier in the infrastructure layer pretty well in place, certainly at the physical level, perhaps, and increasingly at the virtual level. There may be some enhancements and updates required really to fully support a cloud, but it's the trend that most people are already heading. Much of the work in building the private cloud is likely to occur in the middle layers, the consumer management and provider management levels. These are the service delivery layers, and this is where the service provider model that I've harped on earlier comes into play. Creating a service catalog with usage-based pricing, a customer service portal, service automation. This is the groundwork that must be laid for a cost-effective cloud model. From a technology perspective, there are a growing number of elements to support this cloud OS, if you will, layer. At one end of the spectrum, there are loads of open source tools available that'll fill many of those boxes on the previous slide. And at the other end of the spectrum, there are a wide range of vendors busily working on delivering commercial offerings, and this ranges from startup companies to well-established companies. I will say at the outset, the list of names here is way too small. They're just representative. I didn't want to build a long list and then omit people. So just view those. These aren't the recommended list. These are representative, a representative list. And in the middle, there's also a trend towards industry collaboration. So taking some of these open source tools and qualifying them and putting them together in defined releases, that's especially reflected by things like OpenStack. And it's well worth checking out those options as well in considering cloud technology to support your cloud OS. Clearly, building a cloud completely based on open source tools requires a pretty high level of technical expertise in an area that most organizations lack today. And the traditional trade-off, going the commercial route, incurs a more significant investment in things like licensing. But the key here is that there are choices, and they're growing choices, and it's well worth considering several options, regardless of which end of the spectrum you lay, to find the one that best aligns with your organizations. So for the foreseeable future, the transition to the cloud is going to be a balancing act. There are going to be legacy environments that are going to continue to exist side by side with newer cloud models. So what this means for IT is that IT is going to become a portfolio manager of services. Delivering some of those services are going to be delivered in the traditional manner, delivered and operated and maintained and managed by IT. Some of them are going to be delivered and managed by IT within a private cloud, and others are likely to be, from a portfolio management standpoint, existing in a public cloud. I think I've emphasized some of the requirements and talked about the benefits. I'm not going to rehash them again here, but just to say that this isn't an overnight change. It's a transformational kind of change. It does offer a really high level of promise, capability to realizing higher service levels, better delivery, and a brighter future from an IT perspective for organizations.